The Diels-Alder reaction is a 4,2 cycloaddition to give a cycloalkene. It can be done using alkenes or alkynes. This first example is an alkene. Here is 1,3-dibutene. This is going to react with an alkene. The alkene, it's important for it to have an electron withdrawing group, making the double bond here more reactive. The electron withdrawing group can be anything that withdraws electrons: cyano group, carbonyl group, an alkyl halide, any of these kind of things. That's going to pull electrons away from here. When this reaction occurs, it happens in a concerted step. All of these things take place at once. This double bond will break, and one electron, if you imagine this double bond being split into two, one electron here, one electron here, one of these electrons will go to this carbon, and the other will go to this carbon, forming new sigma bonds. Again, thinking of this double bond breaking in half, one of these electrons will go over here, one of these electrons will go over here. This is now a new sigma bond. Just where I change colors. New sigma bond, new sigma bond. There is still a leftover electron here and here. These leftover electrons go into a new double bond that will form here. And this is the result: a double bond and two new sigma bonds. And to have a look at what's going on, it's often easier to see in a line diagram. So here's 1,3-dibutene, here's the alkene, and this is the result. A cycloalkene, the double bond has changed place to right in between where the old two double bonds were, and the sigma bonds take the place. Here's the electron withdrawing group. This can also happen in alkynes. It's basically the exact same thing. Same thing, 1,3-dibutene. Here's an alkyne. Electron withdrawing group as well. It can be any of the examples used earlier or something different. Same sort of thing takes place. The only difference is that there are two double bonds in this cycloalkene ring. Here's the electron withdrawing group. Here's a double bond from last time. The only difference is this time, since only one of these double bonds is used up, there's still going to be a double bond here. To look at the line diagram, here it is. So that's all we'll go over for now. I'll go over the stereochemistry and the endo rules in another section.